Hi everyone. In this video, we will see that how to get the Thevenin equivalent circuit for a given network with and without the dependent sources. So let's begin. So let's first understand that what is the Thevenin theorem and where it is being used. So as per the statement, any two-terminal bilateral linear DC or AC circuit can be replaced by an equivalent circuit consisting of a voltage source and in series with a resistor for DC circuit and impedance for an AC circuit. So this theorem is helpful to reduce a complex circuit with an equivalent circuit which just consists of this is the Thevenin equivalent circuit which has the only one voltage source and in series with the resistance which is known as Thevenin equivalent resistance in case of DC circuit, and this will become ZTH in case of an AC circuit. So here which we need to understand that we need to remember that it is only applicable for bilateral linear circuit, which means that bilateral components like resistor, inductor, capacitor, they do not change their property or they do not change their characteristics in the circuit if their terminal of the connection has been reversed in the circuit. Whereas the unilateral components like semiconductor devices such as diode, thyristor, they change their characteristics if their terminal connection has been changed in the circuit. For simple example, if a diode is connected something like this, in this state the diode is in the forward bias, and these two connections, if these two terminals are being reversed in the circuit, so the diode now being connected as like this, and in this case my diode is becomes the reverse biased. So here the property of the circuit has been changed. In this circuit it was behaving as a short circuit, and in this the second circuit it is behaving as an open circuit, so the whole characteristics of the circuit has been changed. So therefore the Thevenin theorem is only applicable for the bilateral components and the linear circuit, whether it is a DC or AC. So to get the Thevenin equivalent circuit, we need to find out the two values. One is the VTH and the other one the RTH. So first let's understand what are the methods to find out the RTH. So the method one is if we have a given circuit, so we can replace all the sources. I mean that is the current source or the voltage source, whatever the sources are there in the circuit, those sources can be replaced with their internal impedance, and then the equivalent resistance can be find out. So while the replacing the sources with their internal impedances, my voltage source gets become short circuit and my current source becomes open circuit. Why so? Because the voltage source, if let's say I'm just taking a voltage source over here, if my voltage source has the internal resistance connected in series, so this is the complete voltage source which I uh, get or which I take in the circuit. So here on, if the R internal of this voltage source is high, so most of the voltage being dropped across this resistance, because the current, if they flow in this direction, the most of the voltage will be dropped across the internal resistance value of the voltage. So therefore ideally the resistance of my voltage source, the ideal voltage source, should be as equals to 0 or approaching to 0 or as minimum as possible. So therefore ideally we say that the internal resistance of my voltage source is approximately 0. Similarly, for the current source, the internal resistance of the current source is being placed in parallel with it, and therefore this internal resistance should be equals to the infinite. Why? Otherwise uh, the current source, if the resistance value of this internal resistance value of the current source is minimum, the maximum or most of the current will flow within this loop, and we will not get any of the current for the outside circuit or for the connected external circuit. So therefore, this internal resistance of the current short source should be as high as possible, or I would say the ideally it should be infinite. So while replacing the sources uh, to find out the Thevenin equivalent circuit, the voltage source becomes short circuit and the current source becomes open circuit. So it is not like that we are shorting something or open something. It is just that we are replacing the sources with their internal resistance. So this is the method 1. In method 2, this is the method to find out the RTH, that let's say the Thevenin equivalent, we need to find out a Thevenin equivalent circuit for this. Let's say I have taken an example over here, and this is, let's say, R1 and R2, and we need to find out the Thevenin equivalent circuit across A and B. So the second method says that we can short circuit these two terminals, and then we should find out the value of this current which is going through this short circuit path named as ISC. And once we get the value of this ISC, then as per the method 2, the RTH value becomes VTH upon ISC. VTH is the Thevenin equivalent circuit, Thevenin equivalent voltage which we anyhow need to obtain. So this is the method 2. The method 3 is that replace all the independent sources and connect a test source across open circuit. So if I'll just take this circuit itself over here, so we have one voltage source here, so that can be replaced with an internal resistance, so that becomes the short circuit, and the rest of the circuit, to find out the RTH, the rest of the circuit here, we can apply a test voltage across the terminal A and B, and this terminal voltage, let's say give it a name, a VDC, and then assume that this is giving 1 ampere current in the circuit. This voltage source is giving 1 ampere current in the circuit. So therefore, if we are able to find out the VDC over the current which is given by this voltage source, let's say I'm assuming that 1 ampere, so 1, so that becomes is nothing but the RTH. So anyhow, in other words, we can say that VDC becomes the RTH for this kind of a third method. Now here, the third method is specifically useful if we have the dependent sources in the circuit. Dependent sources are those sources whose value depends on some other quantity or some other value which is happening in the circuit. So taking these three methods, now we can understand that where to apply method 1, where to apply method 2, and where it is easy to apply method 3. So as we have considered all these three methods to find out the RTH, now we are able to compare all these three methods. If we have only independent sources in the circuit and we don't have the dependent sources, so this becomes the case 1. So if we have only the independent sources in the circuit and there is no dependent sources, so all three methods are applicable to find out the RTH. However, the best method or the easiest method to find out the RTH if we have only the independent sources in the circuit, that is the method 1. So it is the easiest one. If we have both kind of a sources in the circuit, dependent as well as the independent, then only method 2 and method 3 are applicable to find out the RTH. As method 1 we cannot apply, where we have to replace all the sources by their internal resistance, so it is not applicable for the dependent sources. Why so? Because the internal resistance value or the information of the internal resistance value for the dependent sources it does not belongs to us, or we can say that it is not with us. So we do not know that what is the resistance of the given dependent sources, internal resistance of the given dependent sources. So therefore we cannot replace them by their internal resistance. So only the method 2 and method 3 are applicable for case 2. Case 3, that if we have only and only dependent sources in the circuit and we don't have the independent sources. So in that case, only method 3 is applicable. So we cannot obtain the method RTH with the method 1 and method 2, only the method 3 is applicable. And similarly, if we don't have any sources in the circuit, neither dependent nor independent, then method 1 and method 3 are applicable to get the RTH value. So I hope now we have understood that where to apply the different methods to find out the RTH. Now we can understand the different cases with an example. So let's take the case 1 where we have only the independent sources in the circuit. So here we have the two sources in the circuit. One is a voltage source, other one is a current source. To find out the RTH, we simply need to replace the sources with their internal resistances. So therefore the voltage source becomes short circuit and the current source becomes an open circuit. So the circuit uh, becomes, or it get modified like this. Here the current source gets open circuit, and then we have the 4 ohm resistance, and these are the terminal where we need to find out the Thevenin, across which we need to find out the Thevenin equivalent circuit, and this becomes the 4 ohm. So as we can easily see that the 5 ohm and the 20 ohm, they are in parallel, and the combination of these two will become in series with the 4 ohm. So simply the RTH becomes at the parallel combination of 20 ohm and 5 ohm becomes 100 divided by 25, which is becomes 4, and plus 4. So the total RTH becomes 8 ohm. So this is how easily by using method 1 we can find out the RTH if we have only the independent sources in the circuit. And similarly, to find out the VTH for this circuit, we can apply, let the VTH is nothing but the voltage across these two terminals. So this becomes the VTH. So we can easily apply the application of KVL and KCL to get the value of the VTH. So to find out the VTH over here, we can easily see that this is an open circuit. This is an open circuit, so there will be no current across through the 4 ohm resistance. So therefore, the VTH becomes equals to the same node voltage over here, which is already denoted as V2 and V1. So V1, V2 and VTH, all three will be the same. So I can say that the VTH is nothing but the V2. So if I'm able to find out the V2, I will get the value of the VTH. Or my favorite, the simple one, that here I can see that the one current source in parallel with the resistance is placed over here. So I can convert this source into the voltage source. So therefore this is nothing but the source conversion, and my new circuit will be like this, that I already have the 25-volt source over here in series with 5 ohm, and here I will have again this in series with the 20 ohm and a voltage source of which is equals to the 60 volt. 20 into 3, so that becomes the 60 volt source over here with this polarity. So this becomes the 60 volt, and this is nothing but these are the terminals A and B across which I need to find out the VTH. So this becomes the VTH, and then now VTH is nothing but the, let's say if this loop current is I, so VTH is nothing but the this will be the voltage drop across made the 20 ohm. So VTH is equals to 20 I plus 60, and I can easily find out that I is nothing but this is the total voltage in this loop, which is 25 minus 60 divided by 25. So that becomes my I. So this is nothing but I is equals to minus 35 divided by 25. So this only shows that the current direction, the actual current direction, instead of the clockwise, it will be the anti-clockwise, and it is can be easily seen that 60 volt source is more than the 25, which has the opposite polarity in this circuit. So this is the case 1. Further to this, now we can take the case 2. So here in this circuit, we can see that we have both the sources. One is the independent source, which is the 50 volt voltage source, and the other one is the voltage dependent current source. So this is my current source, which depends on some value uh, of voltage which is happening, or which is given in the circuit, that it is the voltage Vx, which is nothing but the voltage drop across 60 ohm resistance. So therefore this current source, which is the dependent sources, its value depends on a voltage drop happening somewhere in the circuit. So therefore this is nothing but the voltage dependent current source. So to find out the RTH for such kind of a circuit, we have two methods. Either we can go with the method 2, or we can go with the method 3. The method 2 says that we can have the short circuit over here, and then we can find out this current ISC. And of course, to get the Thevenin equivalent circuit, we have to obtain the VTH. So therefore RTH becomes equals to VTH upon ISC. So this is the method 2. The method 3 says that instead of uh, having this short circuit current, we can also get that, let's say that I'm applying a voltage source, DC voltage source in the circuit. Let's say the value of this VDC, and this is given a 1 ampere current source in the circuit, and replace all the independent sources with their internal resistance. So this voltage source becomes short. So forget about this. Now we have short circuited this. So my modified circuit becomes like this. Now I need to find out that value of VDC. If I can find out the value of VDC, that is nothing but the value of RTH, because I have already assumed that it is giving a constant current, which is 1 ampere. So the ratio of VDC over 1 ampere is nothing but VDC, and that value becomes the RTH. So here, if I just look at now, that this voltage source is already given that it is nothing but the Vx, and if we'll apply the KVL through the VDC and in this loop, so my VDC is nothing but Vx. So if I'm able to find out the value of Vx, I will find out the value of VDC, which is nothing but the value of the RTH. So for that, we can easily see that at this node, if I'll apply the KCL, so this incoming current, which is already, I have assumed that it is constant, it is of 1 ampere, and this is the outgoing current. So here, this is nothing but the 2Vx. So this current is nothing but the 1 minus 2Vx. So either I can have here the current division rule further, and then I can find out the voltage drop across the 60 ohm, which is Vx, or we can easily see that this node voltage is nothing but VDC, because here we have applied the VDC and we don't have any resistance here in this branch. So this node voltage is nothing but the VDC. So here incoming current is 1 ampere, outgoing current is 2Vx, and this node voltage is VDC. So now from here also we can form the equation by using KCL, and then we can find out the value of the Vx. The third case is if we have only dependent sources in the circuit. So in this circuit we have two dependent sources. This is the current dependent current source because its value depends on a current of I0, which is this current, and this is the voltage dependent voltage source. It is a voltage source whose value depends on the voltage happening, or which is the voltage drop across the 10 ohm resistance. So to find out the RTH for such kind of a circuit, we have the third method that we can apply a voltage source over here across the terminal of these two. Then let's say this is a voltage source of VDC and it is giving a 1 ampere current in the circuit. So again here we need to find out the value of VDC, which is nothing but the value of RTH. The one thing which we need to remember over here, if we don't have any independent sources in the circuit, then the VTH value will always be 0. So such kind of a circuit, the VTH value will be always 0. So therefore, the second method, which is finding out the value of ISC and then the RTH becomes VTH upon ISC, is not applicable for such kind of a cases. So we are only left with the third method, which is applying a test voltage of, let's say, VDC, which is giving 1 ampere current in the circuit, and then finding the ratio of VDC upon 1 ampere, which is nothing but the VDC, and that becomes equals to the RTH. So thanks for watching this video. We haven't given the solution for the second network and the third network, where we have just given given the brief of how to obtain the equation. So to find out your own answer and put it in the comment box, and let's see that whether you have reached to the correct answer or not. Thank you.